Today I'm going to show you how to use the normal distribution, the standard normal, to solve problems. Let's start with this problem. Probability that z is less than or equal to 0.83 or greater than 0. Graphically, the equivalent would be on the z-axis. You have 0 as the mean. You want the probability or the area under the curve contained between the mean of 0 and 0.83. Shade the area that you're after. Now let's use the normal table to find our answer. 0.83 is 0.2967. This is how you read it. 0.8, 0.03. At the intersection, you see 0.2967. So this area that you look up, 0.2967, is the area contained between the mean and that z-value. You know that because this is how the table in your book is designed. If you look on the z-axis, the center or the mean is 0, and a z-value is indicated, and then the area is shaded. The writing says any number that you look up in the body of the table is the area under the curve contained between 0 and the z-value that you look up. Keep in mind that the normal curve is symmetrical, so from 0, from the mean, the center of it, all the way to the left is 0.5 or 50% of the area under the curve. And from the 0, the mean, and all the way to the right tail is again 0.5 or 50% of the area under the curve. So that the total area under the curve equals 1 or 100% of the area under the curve. The next problem is probability that z will be less than or equal to 0 and greater than or equal to negative 1.57. For this, again, draw a curve really quick. We're working with the z-axis. The center of the z-axis is always 0. We're looking for negative 1.57. Go up to the curve, and now we want z to take on values between 0 and negative 1.57. So that's this area. Again, we can directly use the numbers in the table. Look this up. Z is equal to 1.5, 0.07. At the intersection, you see 0.4418. 0.4418. So this area right here is 0.4418. Of course, we know, due to the symmetry of the normal curve, we looked up a positive 1.57, but because of the symmetry of the normal curve, this area and this area from 0 to negative 1.57 are both the same size. So the answer to this question would be 0.4418. The next question is probability that z will be greater than 0.44. Draw the curve. Center is 0 because we're working with z values. We want z being greater than 0.44. So mark 0.44, shade the area that answers your questions. This point on gives us values of 0 that are greater than 0.44. Now we look up the table. If you look up 0.44 in the table, this white area is the answer that we're going to look up. 0.44 gives us 0.17 as the table entry. So I know this area is 0.17 because any number that I look up in the table is going to be the area between the mean and that z-value that I looked up. So I know this white area is 0.17. But I don't want that. I want this shaded area. since I know half of the curve is 0.5, to find the shaded area, I can take 0.5, subtract 0.17 from it to get 0.13. And that's that problem. The next one is probability that z is greater than or equal to negative 0.23. Draw the curve. Z is negative 0.23. Go up to the curve, but we want probability of z being greater than negative 0.23. Greater than means all of this area. So already I know that my answer should be more than 50% or 0.5. How do I know that? Because I know this side, this right side is 0.5. And this part right here, I can look up from the table. I go to the table and I look up z of 0.23. 0.23. I get 0.23. I get 0.091. 0.091. So I know this area is 0.091. So this answer will have to be 0.5 plus 0.091 or 0.591. And that's that. Let me just tell you here, whether I asked you to choose probability of z being greater than negative 0.23 or this, both would be the same because we know for a continuous distribution, probability of an exact value of z equals 0. So here we're saying z being greater than or equal to 0.23. Here we're saying probability of z being greater than 0.23. Because the probability of z being exactly equal to negative 0.23 is 0, therefore these two answers should be the same and are the same. So both will give you this answer. Next question is probability that z is less than 1.2, positive 1.2. Draw your curve. We're working with the z-axis, mark it. 1.2 is over here. We want probability that z is less than 1.2. So that would be all of this area. Again, we know just by shading it that my answer should be greater than 50%. How do I know that? I know the left half is 0.5. This area can be looked up. Look at the z-table. 1.20 gives me that table entry is 0.3849. 0.3849. So I know this smaller strip shaded is 0.3849. Therefore, the answer to this problem is 0.5 plus 0.3849, which is 0.8849. Again, here, whether I had probability of z less than or equal to 1.2 or probability of z being less than 1.2, either way, I get the same answer, which is over here. And finally, probability that z is less than negative 0.71. Draw. Mark what you know. We want z to be less than negative 0.71. Less than negative 0.71 would be this strip right here. So I need to use the table to find 0.71 on the z-axis. I see a reading of 0.2611. 0.2611. My knowledge of that table that I just saw tells me that this area is 0.2611. So this shaded area would be 0.5 minus 0.2611. So the answer is 0.2389. Thank you.